Maybe you show the names of the videos, so at least, and if there is a some kind of index of topics in each video, I don't know if there is, then maybe should be there. Usually it is about what they are talking about. Yeah. So I think first of all, superb videos, right? Really, really well explained for anyone uh, completely non-technical. Also, it's I think should be easy to understand. Of course, complexity increases dramatically in the fourth video, just simply because of all the notations and references to calculus and all that. But I think he has a video on calculus as well. So a few videos on calculus as well. So if someone wants to brush up on their basics of calculus, those videos are also helpful. But yeah, I think uh, in terms of the first video, it looks like very simple definition and explanation of what are neurons, what what are layers in neurons, and how they mimic in some way or form biological neurons, even though the layers are not as strictly defined biologically. Um, then we he took us through edge detection. So there is a data set of numbers in a 28 by 28 pixel. How many was it? Yeah, 26 by 26. 28 by 28 pixel matrix uh, where these numbers are written down and kind of defined or labeled, and how it is taken through this neural net and how it eventually spits out a single number from these 784 pixels that you have started with. So I think it's explained very intuitively. It's difficult to do it without um, anything, any kind of aid right now. Ideally, I would love to have drawn it on a board, for example. But no. Pick a tool and start drawing. Basically. Yeah. Yeah, maybe just to quickly put that grid in front of us. And ideally, we don't want to get into all the explanations again, but even from a grid of, let's say, 6 by 6. So, yeah, I mean, the pixel grid, so to speak. Yeah, you can just copy paste the whole thing. Even before that, I want to say that you have a grid of 28 by 28, right? Which is where which is where uh, your numbers are kind of drawn. So if you write the number 6 or whatever number, then it is essentially uh, like sum of the pixels in that grid of 28 by 28 being fully white or fully black, depending on how you see it, and some others being, slightly grayscale or completely black or completely white. So you start with that, essentially, to visualize how this becomes uh, an array of 784 numbers. Maybe even if you take a screenshot of, that might be easier. Hmm. Mhm. 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 And this is done with the hope of trying to kind of extract some features from the input in some way or form. Uh, if we were to take linear regression for our current 784 pixels worth of data and take that as a table, for example, then I don't know what kind of output we will get, but it will be really poor, right? Um, yeah, with linear regression, um, because it's a single, like you are trying to pin the effect of every single pixel directly to um, the output, which is what is that number in total. So intuitively, you can say that it is a very like the linear regression is a special case of a neural net which has only two layers. Mhm. Yeah. करना करके देखना चाहिए. It will be fun. But it will be a lot of calculation, but it will be fun. Correct. Correct. But yeah, I think the first video was just trying to help us visualize what a neural network looks like and what are these weights, biases with respect to each and every neuron in the neural network, and also an introduction to the sigmoid function, which is essentially trying to put everything between a 0 and a 1, correct? Or is it -1 and +1? Yes. Mhm. Hmm. I think they said they are not sure why, but it seems to give better results. That's it. Yeah. Exactly. Huh. Mhm. Yeah, I think the if you try to look back, like how humans are learning or how real neural networks are, you might have a certain set of neurons firing very strongly for a certain kind of input. And I think that's what they're trying to mimic in some way or form, saying, okay, if you believe strongly about something, then it will show up in the neural net in, in a way that it is kind of reflecting that strength. I guess that's a very simplistic way of thinking about it. But math wise, I don't know how it is really. हाँ. लीनियर के तीन चार लेयर मतलब मैं समझा नहीं. हाँ. Mhm. 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 No, but the numbers will go too high, right? ReLU will restrict it between minus one and 0 and 1, and hmm, what is the x-axis on this? Mhm. Hmm. Huh. Hmm. Hmm. Mm-hmm. Mm-hmm. Correct. The cost function is only in the final layer, right? But essentially, it is. Mhm.
No, before that, one question for cost function. This will change for each type of uh, uh, means a problem, or it will remain the same. Like they create the square of the expected output, and then whatever output we got, will it remain always the same like this? Okay. Hmm. one question is there, like consider a situation where I am looking only for two number, right? Two pattern. Okay. So in that case, if I'm changing the weight going propagatively back to the other layer, uh, consider this is one step of mine. I identify some weights which went to the first layer till first layer. Okay. So again, if I run it and I won't get the proper value again for the two after even changing the weight. So again, I will do the same for it, right? For how many times I will do it, or it is the first time only whatever I make the changes and then I will move forward.
You will do it for every uh, you know every image in the training data set essentially.
No, that's fine. So अगर
Yeah.
every image की बात हो गई तो that means I might be moving to three number also, four number also. Consider
Yeah.
I'm just looking for one number, two number. So once I got to the answer, right, first iteration I went to the last layer. I get two number which is not proper. Like I might have got the activation number 0.2, right, as they told,
Hmm.
but I need one, right? So based on that, I made the changes going back. But again, yeah, after changing the weight, I may not get two as a proper number. Even other numbers might be getting the same probability or activation number,
Hmm.
right? So will I again iterate it?
No, not with the same data set. I mean, not with the same individual image data, if that makes sense. Right.
Okay. So once I, so even if the activation after changing the weight is still not good enough, right? I will make the changes again, right? So those iteration I need to do till I get till I trained it to get it a good value, correct? For the two, or I will leave somewhere in between.
No, whatever values you get for your entire uh, network, let's say you start with some certain random values, and then you put this 2 in as input, and you are expecting the 2 as output, uh, but you don't get the 2 as output. So you change the weights
Correct.
and you change, but you change it once,
Correct. Okay.
and you don't check again whether it's still showing 2 or not. You
Okay.
just change it once, but the change won't be so dramatic that it comes equal to 1.
Okay. Okay. Then I will go to another pattern.
Yeah.
Okay, like that, whatever pattern I will. But when it finally decided I need to make the average of every pattern, right?
Yes.
So, but my two activation number was still not correct for the two one. So there could be error probability, right? That's why I'm going
Yes,
for second pattern.
it will always come less than 1. It will not come equal to 1. So when you finally have a fully trained network, then what it gives you on the last layer is a probability of that being a 0 or a 1 or a 2 or dot 9. And typically one of those will be higher, like 96% or 98%, and that will tell you that it is very likely that this is a 2, but it will never be 100%, never,
Correct.
because
So
you can't have a network which will have 100%. It will always be less than all the other numbers will have some very low non-zero number. It's very unlikely that they'll be absolutely zero.
so for single pattern, we will do back propagation only once, and then it depends upon the average of small sets that we give. Based on that we reach to kind of good number.
Yeah. Hmm.
So one more question. In neural networks, we have hidden layers like L1, L2. So do we decide that how many neurons will be there randomly, or there?
I think like stochastic gradient descent was one of the last things that he was mentioning. Essentially, trying to bunch up certain to speed up calculation in some way or form, to trying to bunch up batches of inputs, if you can call it that, right? So the learning is a bit faster versus trying to do it with each and every input, right?
So only idea we are talking about gradient here is because we have equation. Equation is nothing but our cost equation that we need to minimize. That's why the gradient has come to minimize that one. So once you identify that, because it is an equation, so you create you this equation can be influenced by the backward layers also, so that will create a cumulative gradients for you, which give you a kind of direction that till how much magnitude and in which direction you decrease the weight so that you can reach to your goal very fast.
Mhm.
So the gradient has come only because of this equation, which is a cost equation and the cascading effect of the backward layers.
Yeah, basically you have a curve or you have a three-dimensional plane, not plane, what do you call it? Three-dimensional curve, and you want to get to a local minima. So you you get to a minima by looking at the derivative, which is essentially the gradient, and then you descend down that curve. So that's why it's gradient descent. And like you said, you want to do it as quickly as possible versus randomly going anywhere on that curve. Um, yeah, I don't know. Like, Abul? Yeah, I think we can try and put the data set into both a simple linear regression model, see what the error rates are like, and to try and then see different kinds of neural nets, maybe two or three, in terms of depth, in terms of the activation functions as well, and see how the different like output varies. Hmm. वो तो 10 to the power 6 times होगा ना, मतलब। हम्म। हम्म। नहीं नहीं, तुम्हारा हर इनपुट के लिए, तुम्हारे जो 1 मिलियन इनपुट्स हैं, राइट, 1 मिलियन डेटा का डेटा सेट है। एवरी every image that you have on the input side will update every parameter, like all the 10 to the power 3 parameters will get updated every time with the image. So you will, the number of iterations in this case is essentially 10 to the power 6. Now, you don't want to do 10 to the power 6 iteration, you want to do maybe fewer iterations. What is the difference between iteration and the number of inputs? Correct? Hmm. Hmm. Mhm. 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 उससे तुमने एक इमेज से किया ना वो। हम्म। हाँ। हम्म।
I think that's what they told na ki you need to put that batch in a smaller numbers, right? So once you put that batch in smaller numbers,
My only question is, in this four videos, we didn't see anywhere he talked about iteration. Yeah, correct, correct.
So Arjun, it might be okay, like what we discussed, right? For one image, we are back propagating only once. That's what we
Hmm.
discussed, right? So based on if he is saying that iteration is there, they might be trying for two, three times or four times for the same to get the correct weight.
Hmm.
Otherwise, I'm not
Yeah.
sure about that, but it can be done if it is changing, right? Every time if it is changing, you can do that. But only idea, because the problem is when gradient give you the magnitude and the direction, right? It cannot tell you how much you are increasing. Percentage wise, you increase, right? So if they, I don't know, means if the cost is getting decreased, they might be increasing the iteration for it.
Hmm. Ah. Hmm. Hmm. Yeah, I think he has referred to one, some Peter, some guys, open book, right? Hmm. So इसमें कोड भी है क्या? हाँ. हाँ, ये आई थिंक रिसेंटली उसने किया था, राइट? ओके।
Hello, my name is Andre.
हाँ। हम्म। I think conceptual understanding is quite clear. We don't need to get into that much detail. We can work at a slightly higher level of abstraction.
Yeah, this I think we can build on top of it based on different scenarios, like what cost function we need, what kind of cost function we have, all that to identify it. But impact we need to know that we already know that how it what things impact.
Yeah. Mhm. What is the difference between MNES and fashion MNES? Mm-hmm. Mm-hmm. This whole thing is hosted on AWS, or at least their storage is on AWS. You don't know about the compute. Mm-hmm. Stochastic. Batch size is that only. Yeah. So basically, you are doing in batches of 64 each, correct? It will be basically how many pixels by how many pixels, right? Multiplied by 60,000, correct? 28, 28 by 28 multiplied by 60,000, correct? So you can use a function to just show what is training data 0. Like it will show you a boot or something. Like you can actually plot it pixel by pixel. Hmm. Huh. Yeah. Of 28 by 28 pixels each. Mhm. एक बार बैच साइज का डेफिनेशन देखना अंडर डेटा लोडर. हाउ मेनी ऊपर ही था सेकंड. हाउ मेनी सैंपल्स पर बैच टू लोड.
Like for example, if you have 1,000 samples, right? उसको वो डिवाइड कर रहा है इतने में. फर्स्ट उस पे फिर जो भी आउटपुट आएगा देन इट विल टेक एवरेज आउट ऑफ ऑल दैट. एवरेज का भी एवरेज कर रहा है.
I don't understand. Like, why do you need a batch? Why can't you do it one by one? But eventually, you will still do. Uh, you will still calculate all of them, right? हाँ.
नहीं, मेरे को ऐसा लगता है कि ये स्पीड के लिए कर रहा है. somehow he will do it parallelly. I don't know.
हाँ. Hmm. Hmm. I'm not clear. Hmm.
अच्छा, एक क्वेश्चन है, मिलन, एक क्वेश्चन है कि ये जीपीयू अपन यूज कहाँ करते हैं इसका? उससे रिलेटेड मेरे को लग रहा है कि आइडिया होगा, तो जो मैंने बोला है राइट, कि बैचेस अगर वो पैरेलली करता है और उसको करने के लिए जीपीयू का यूसेज करता है, तो इट मेक्स सेंस। ओके। ओके। नहीं, अभी जो डेटा लोडर में जो डाटा है वो हमारे पास, और हाँ, करेक्ट। हम्म। करेक्ट। हम्म। 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 नहीं, नहीं, वो मैं वो मैं समझ गया, लेकिन यहाँ पर जब वो 64 ले रहा है ना मिलन, तो वो 64 बैच नंबर जो डिसाइड कर रहा है वो किसी कैलकुलेशन के बेस पे नहीं डिसाइड कर रहा कि मेरे पास इतने पैरामीटर हो जाएंगे तो इसलिए 64 इज द राइट नंबर, राइट, कि ये बड़ा हो गया, अब इतने पैरामीटर्स मेरे पास हो गए तो ये बड़ा हो गया नाउ, अब मेरे को प्रॉब्लम। हाँ, हाँ, हाँ। ओके। हम्म।
एक बार ये मॉडल ऑफ एक्स जो फंक्शन है वो, हाँ वो लाइब्रेरी में ही देखने बोल रहा हूँ मैं कि भाई वो व्हाट एग्जैक्टली इज इट डूइंग. Okay. And in that, what are you doing? Are you randomly assigning all your weights? Right. Mm-hmm. बराबर. Hmm. Mm-hmm. Correct. Hmm. Mm-hmm. Mm-hmm. Hmm. Hmm. तो एक जस्ट वन क्वेश्चन, ये जो लॉस फंक्शन है, लॉस इक्वल टू लॉस फंक्शन प्रेडिक्ट एंड वाई, it is for every sample that you have given, it is a there is a loss, correct? Is it a summation of all those losses? Like, yeah, average. It is a is it a single number? तो लॉस का अगर तुम ये देखोगे, डेटा शेप और whatever you want to call it, you will see a single number, float. Sorry. Hmm. Hmm. हाँ, वो तो करेंगे.
नहीं नहीं, ये एक्चुअली क्या है, लॉस में जो एक सिंगल वैल्यू आ रही है वो इसलिए आ रही है क्योंकि ये जो वाई वैल्यू आप दे रहे हो ना साथ में लेबल, तो उससे वो एक्टिवेशन नंबर पता कर लेता है कि कौन से एक्टिवेशन का लॉस निकालना है मेरे को. जैसे 2 का निकालना है, राइट? तो लास्ट में अगर आपके 10 वैल्यूज रह गई हैं, राइट, तो उसमें 2 का कितना लॉस आ रहा है मेरे पास. तो आई फील कि ये उसका ही पर्टिकुलर न्यूरॉन का लॉस निकाल के देता है जिसमें हम प्रिडिक्शन करने की कोशिश
एक बार ये लॉस फंक्शन का खोलना, डेफिनेशन. हाँ. Mhm. average negative log likelihood of collect class probabilities for the entire
एवरेज
batch.
मतलब कि बैच का जो भी, जैसे मान लो आप बैच में चल रहे हो, राइट? तो बैच में दो का जो पर्टिकुलर वाई लेबल का जो है, राइट? 64 में जो वाई लेबल के जितने भी आ रहे होंगे, आई थिंक सभी वाई ही आ रहे हैं, करेक्ट? आई एम नॉट श्योर। तो वाई का जो भी एवरेज आ रहा है उसी का लॉस दिखा रहा है वो, मतलब आई थिंक।
For every sample, there will be a loss, correct? Now,
हाँ, फॉर वाई लेबल।
back propagation. हाँ. नहीं वो मैं समझ गया. I'm trying to understand what is this loss for a batch of 64. That negative log function that he's saying. Mhm. So this is probably sigmoid or something. हाँ, not activation. बेसिकली तुम्हारा फाइनली जो नंबर आया उसमें से तुमने देखा कि ये रूट मीन स्क्वायर एरर है या क्या है? लॉग लॉस.
इसके हिसाब से तो ये है कि 64 बैचेस जो आ रहे हैं उसमें अगर ये 2 नंबर का जो आइडेंटिफिकेशन है उसका एक एक सैंपल के लिए कितना डिफरेंस आया, ऐसे 64 के लिए कितने डिफरेंस आए और उसका एवरेज।
जस्ट उसके ऊपर ही फॉर्मूला था दैट आई मीन इट लुक्स वेरी सिमिलर टू दिस. हाँ, if your 2 should be recognized as a 2, then your probability of or your the actual number coming out for the class identifier of 2 should be close to 1, right? So multi-class setting is a true probability of class I. ठीक है. Typically 1 for the correct class and others is 0. Yes. And log of Qi. Okay. Predicted probability of class I from the model. ठीक है. तो log of that. So log अगर log of तो द बेस क्या है ये? If the number that is coming is closer to 1, then what will that pi log qi look like? Log of 1 तो कोई मतलब नहीं रखता है. What is the base in this log? उसको पूछो. चवली पिलाने में कॉन्फिडेंस. हाँ. Yeah, I'm just trying to understand like what will this number look like? Like let's say hmm, correct.
नहीं
It will be close
नहीं
to
नहीं
0 because we so it will not penalize it much if the prediction is correct. If the prediction is wrong, like it you wrote a 2 but the actual classification was let's say 7, then P7 का तो 0 हो जाएगा. P7 multiplied by so then the negative of that will be very high. So it will penalize, like it's saying, if the model predicts a high probability for the correct class, the loss will be low. If the model predicts a low probability for the correct class and thus a high probability of incorrect class, the loss will be high. So that's the core of this loss function. And this is done as a summation for all the these things in a batch, correct? All the samples in a batch. Makes sense.
नहीं मतलब ये जो कंसिडर कि 2 सैंपल भेजा था बट 7 आया है, तो इसका जो P1 है, P1 को क्या बोलोगे फिर आप?
P0 से P9 है, right? P0
हम्म
being 0, P9 being 9. And in this case, you wanted it to predict a 7, correct?
ओके
But it was actually predicting a 2.
हाँ,
तो तुम्हारा
तो उसमें जो P1 जो मेरा है प्रिडिक्शन का 7 के लिए था, राइट? करेक्ट, हाई होना चाहिए, करेक्ट?
so P7 would be 1, all the others will be 0,
करेक्ट.
right? And log of Q7 will be essentially quite high in this case because log of 2 is coming to be 1, but उसका कोई मतलब नहीं है. Log of Q2 will be 1, but उसका कोई मतलब नहीं. So log of Q7, which should be closer to 1, but it is actually low. So your P7 times log of Q7 will be a high number, which will give you a negative cost for this, a highly negative cost for this.
So that becomes वो gradient वाला issue हो गया, right?
एक बार इसमें पूछ के देखना मिलन, what is the base of this log, because that will or should make a difference, right? Because जैसे जो negative है वो positive हो जाएगा. इसको पूछ के देख log, इसमें log base क्या है? Base E. हाँ, correct. नहीं, वो जीरो तब होगा जब तुम्हारा प्रेडिक्शन करेक्ट है. जब तुम्हारा प्रेडिक्शन रॉन्ग है, like it is confidently saying it's a 7, but it is actually or rather it's confidently saying it's a 2, but it should be a 7, then your log of q7 will be a high number, high as in absolute values. It will not be close to 1.
नहीं, लेकिन
It
यहाँ
will
पर
not be
Q
close
की
to 0.
लेकिन यहाँ पर Q की वैल्यू आई कहाँ से? मतलब Q का एक्टिवेशन नंबर की बात कर रहे हो क्या?
Q is the probability that you get, मतलब तुम्हारा जो अरे आता है of 10 digits, 10 numbers, Q0 से लेके Q9 तक. अगर तुम्हारा let's say prediction is 2, then Q2 will be close to 1 and all the others will be close to 0.
लेकिन यहाँ पर आपका प्रोबेबिलिटी 2 का 1 आया, राइट? मतलब जो
I mean close to 1 आया, close to 1 आया. हाँ. नहीं, P0 से लेके P9 तक है ना. तो अभी तुम सेलेक्ट कर रहे हो इंफिनिटी हो गया ना. What is log of 0? Undefined. It's like dividing by 0. Log of 1 will be 0 ना. तो समझ रहा है, तो वो नेगेटिव, the effect of that will be very low if it is a correct prediction. हाँ, correct. हाँ, तो वो in practicality it will never be equal to 0. You will never get a QI equal to 0. It will always be a very, very low negative number. I mean, the more you go closer to 0, the higher it will get. The absolute value of that. See? But it doesn't matter because basically you you will get a number closer to 0 for log of qi if more or less your prediction is correct.
मतलब अगर आपका Q1 की वैल्यू कहीं पर भी 1 आती है देन इट इज ओके, अगर 1 नहीं आती है तो जितना भी वो नीचे चलता चला जाएगा उतना आपको डिफरेंशिएशन ज्यादा करना पड़ेगा उसको ठीक करने के लिए.
हाँ, मतलब 1 आती है फॉर द राइट प्रेडिक्शन.
हाँ, राइट प्रेडिक्शन.
हाँ,
मतलब आपने, लेकिन यहाँ पर क्या हुआ कि 7 के केस में उसको 1 कर दिया, फिर लॉग में जो 7 का प्रिडिक्शन आया उसने जो एक्टिवेशन नंबर 7 को दिया है वो Q हो गया हमारा, राइट?
करेक्ट.
तो जो वो Q को जो नंबर मिला है वो हर समय अगर 1 के अलावा जितना भी नीचे जाता है उतना हमारा गलत प्रेडिक्शन है. गलत जितना नीचे जाएगा उतना ही हमको उतने ही मैग्नीट्यूड पे हमको चेंज करना पड़ेगा उसका वेट.
हाँ, कितना वेट चेंज करेंगे आई डोंट नो इफ इट विल डिपेंड ऑन द मैग्नीट्यूड ऑफ द लॉस. आई थिंक इट विल डिपेंड एट सम लेवल ऑफ कोर्स. But yeah, basically you are doing it for a batch and then you are propagating the weights back.
करेक्ट. तो बैच में अगर हम कर रहे हैं तो उस बैच में वो उतना मतलब अगर समझ लो कि आपने ये बैच को डिवाइड किया 64 से, राइट? तो आप 64 टाइम्स करोगे तो 64 का अगर आप एवरेज लेते हो तो आप उस एवरेज से भी सबको एक बार में कर सकते हो, इसका मतलब, राइट?
वो एवरेज अगर तुम्हारा क्लोज टू 0 निकले, which then it would mean that your model performs reasonably well for this batch of 64.
करेक्ट. तो वो वेट को ज्यादा चेंज करने की जरूरत नहीं है, इसका मतलब.
Correct. But if it comes to be more negative, then you realize कि हाँ, we have to change the weights more, so the gradient descent works more aggressively, so to speak. Good. This was quite illuminating. Negative